prototypes. I don't know.
Now, an interesting theory in fuzzy sets in medicine is by CwW, and he's doing the same. He created a theory of family resemblance and prototypes. So he used this linear wash concept. So he did the same as you in this part. He did it in medicine. So my question is it necessary to have both?
Perhaps changing the meaning of the predicate, I can move from non-normal to normal. This is not a problem. This is not a problem.
Go to the next slide. Yeah. But still, it requires that they have some, even after moving, you require that they have some common prototype. Because you said the S of mu and the S of sigma have to be non-empty. And that is what is a little bit far from what Wittgenstein said. There is nothing in common, even though they have family resemblance. They can be family resemblance and they don't have nothing.
I only have an answer. Improve it.
No. What's that?
No, I agree with you. Try to improve it. I was looking for that one. Sometimes I was not able to consider the cases in which one of these intersections is empty. Why mainly? Mainly for these cases. That is this case. Because the problem that which I started to was when the two fuzzy sets represent two different uses of the same predicate, in which I think that they should be family resemblance. Nobody will accept that this fuzzy set level and this fuzzy set mu can represent two uses of the same predicate. And for me, these two examples are crucial. One in which I can agree that these are two different uses and they show family resemblance, and this in which, again, nobody will agree that this is two different uses and there is no family resemblance. If you can improve, let me say, our theory, quotation marks, our theory, considering these points, excellent. I was not able. Please.
I have a couple of questions, another comment. First of all, is very interesting because if you look at your discussion, when I talk on philosophical aspect of what you said, as far as I remember, in his book, Philosophical Investigation, he stated two important things now related to what you said. One is, he said, concept game is a concept with blurred edge. I understand that text means extension of a set is not clear. Okay. And also he said there is nothing common but similarity or family resemblance. In one sense it means intention of a set is not clear. But anyway, in such a way, similarity is deeply related to family resemblance. You precisely introduced similarity relation into a family of family set of family resemblance, not a grievance relation, of course. And now my second comment is, in your definition of family set with family resemblance, you mentioned if one member function increases, then at the same time the other also increases, decreasing, etc. That property is generally called co-monotonicity. And then my third comment is, you introduced a kind of distance or similarity or indissociability between family of fuzzy set with co-monotonicity. But as far as I find, your definition is not restricted to family or physical with monotonicity. Your definition can be applied any to cell. So therefore, I think it may be better to restrict your definition on family or physical with co-monotonicity.
Yeah. The problem of finding dysfunction, or another way, is the properties dysfunction should satisfy in relation with the family response. And I was trying this for a lot of time. Looking, which property a tubarial function should verify that I can call this function a family resemblance degree? I was never able to find this property.
My point is, if you take that integral, okay,
Yeah.
you must think back.
Yeah.
It means we forget the structure of your family function. It has structure of comonotonicity.
Yeah. Now this is a typical W distribution. There are others, of course, because, for example, it is not necessary to take just the WT norm. You can take a T norm in the family of the over 60 norms. But then I will need to introduce an order automorphism, and that will complicate a lot the computations. But of course, maybe it is possible to things. Not to take a protein distinguishability, but an indistinguishability with a norm in the family of protein. And not taking a W indistinguishability, but an indistinguishability with a norm in the family of that. This is possible. In my view, what will be ideal is to have two different indistinguishabilities in the family of protein. And my problem was that I was not looking for two different functions at once. That is a problem. Okay. Any other question?
I would like try to go ahead with it, to try to inspire you to go ahead. We are looking very near the shape of the linguistic level, but perhaps what we are trying to do is to extract some parameters of that profile. Not the profile, but the parameters of the profile. That is the thing that you have made choosing these two measures of indistinguishability. But if we extract some parameters that, in fact, we are going to collect a vector of characteristics related with each one of them, and then to measure the distance between these two vectors. That is the case now, but you could broaden a lot the landscape of your work. If you don't work so near the linguistic levels, but in a new space, a vector space of characteristics. And then at that point you can introduce in the future all the things that you can imagine, because even the Wittgenstein approach to language, because we can introduce the characteristics we like. That is user-dependent, the definition of that vector of characteristics, and of course also the distance that we are going to use.
Well, look at this. Is a indistinguishability. Hence, 1 minus dr is a distance. Each time we are using indistinguishabilities, we are using distances. For example, in this case, the distance will come through a transformation by minus logarithm. But in any case, a T indistinguishability is associated with a distance. That in the case of the T norm W is the easiest case, because it's 1 minus dr, but in the other case it is. That is, this idea of having a distance is here.